provisioning functionality for both relational and non-relational database engines, and to continue to improve its fully featured and extensible open source framework. That's quite a lot going on in that one sentence, but there are some salient points there that I've highlighted that I just wanted to quickly go over. The main one to try and understand is Trove is not a layer that sits between your application and the database, right? So Trove is only a provisioning engine. So if you look at the diagram there, you see if you talk to the Trove APIs to provision your database, Trove gives you an instance of your database, and then your application talks to your database directly for its database needs. So key to understanding, Trove is a provisioning framework. It does some lifecycle management as well, but you're not going through Trove to write or read things from your database. Like other OpenStack services, we strive to be scalable and reliable. Another important thing about Trove is that we don't only handle relational databases. Initially, when we were incubated and integrated in the Icehouse release of OpenStack, we supported just MySQL, which is a relational database. But we've come a long way since then. We support a bunch of non-relational NoSQL databases as well, provisioning them. So that's part of our charter. And finally, we're an open source framework. So we're part of OpenStack. We do a lot of things the OpenStack way. We ship with the regular OpenStack cycles. Our code is on the OpenStack repos. We do the code reviews. Our tests are in Tempest, et cetera, et cetera, et cetera. So mouthful in that one sentence, but hopefully you have some understanding of what Trove actually is. So again, I can't, this is just an example, an analogy between Trove and a vending machine. Trove is, so you walk up to the Trove API and say, hey, I want a can of Redis, or I want a Redis instance. And so Trove gives you an instance that's spun up that has Redis on it. It's tuned, and then you basically have a connection string and IP to your Redis instance, and your application can then connect directly to that Redis instance and do what it needs to with that Redis instance. There's a plus there because Trove, the analogy is a little bit more than just a pure vending machine. Trove does some lifecycle management of the database even after it has handed off the database to you. You can call Trove APIs to do things like back up your database, create another database that's restored from that backup, set certain configuration parameters in the database to tune it as you'd like, things like that. So, but the idea here is that it's more of a provisioning engine than an actual database API. So why Trove? Why not just go out and provision your own Redis instance or MySQL instance, right? And apart from the obvious answer that, hey, it's a REST API that lets you do this easily, and you don't have to actually go install the packages, create the users, do things like that. Broadly, what Trove does for you falls under three categories. And the first one is sort of Trove takes care of the management, the lifecycle of that database. So under this category, basically Trove, with the Trove API, you can do things like resize your database size, the flavor size. So for example, you created a database that was a small database. The app that you were using suddenly became popular. Now you want a medium flavor, or you want a large flavor. So Trove has an API that you can specifically just call that will resize. Underneath the hood, it uses the Nova resize APIs, but it will resize your instance so that now you're running on a newer, upgraded flavor. Trove, under the covers, uses volumes to back your data files. So say you initially had a volume size of 10 gigs, and now you realize 10 gigs is too less, your database is growing, you need to double it to 20 gigs. So using the Trove APIs, you can quickly call Trove and say, hey, double my volume size, and Trove will do that for you. I spoke about backup and restore earlier, so that's something that the Trove APIs allow you to do as well. There's also data store specific extensions in the Trove API. So this is more for convenience. You could sort of create, so if we were talking MySQL, for example, you could create a MySQL user and MySQL database, grant user access to that database so that you wouldn't have to do that in your app, for example. Or if you don't want to do users in database specifically, you could call a Trove API to enable a root user and basically then take that root user and use that root user to do what you want. So apart from lifecycle management, Trove also does tuning of the database underneath. So if we take the example of MySQL in this case, a standard Trove install of MySQL, when it brings up a MySQL database, locks it down to be InnoDB only. These are, of course, default options. You can override these if you want a different way. But the idea is that you could set up your database install for the database that Trove's hand to you, tuned to the way you want it. So another thing we do is disable load data in file and select into out file, because it has security and performance implications. Another thing that Trove provides for you is it gives you a templating language that allows you to tune database settings per flavor. So for example, if you're looking at MySQL myconf settings like buffer pool size or max connections, you probably want those numbers, like you want fewer max connections in case you're using a tiny instance as opposed to a large instance. So with Trove's templating language, it uses Jinja templates under the covers, but you can specify certain configuration parameters the way you want them to be per flavor. And if that isn't sufficient, you can also specify programmatically through the API what the user can override. So as a deployer of Trove, you could say, hey, it doesn't matter if I specify my default max connections for the large flavor to be 150. Users can set it to what they want through this configuration groups API. So Trove has APIs to do that as well. And finally, what Trove does is it gives you an instance of a secured database. So underneath the covers, Trove is actually securing that data store instance. And some things that Trove does by default is removes anonymous users from the database, removes non-local host users, so only users that are explicitly created via the API have access. Removes local file access. If there's a default root password, it mangles the default root password so folks can't connect using default passwords on certain services. It also has a concept of security groups. So if you want your database to only be connected to from a certain set of IPs, you could specify that in the Trove security group, and it will only allow access from those IPs. So any questions on that before we move on further? Cool. So I mentioned this earlier. When Trove was first integrated in Icehouse, we supported MySQL, and since then we now support a lot of other data stores in Trove. So as of Kilo, which is the last release, we support for clusters and replication MySQL, MongoDB, and HP Vertica, which supports a 3-node cluster for the community edition. And we also have single instance support for a bunch of newer databases, and we're working on getting some of these to be clustered in Liberty. So we have single instance support for Apache Cassandra, CouchDB, Couchbase Server, IBM DB2, Postgres, and Redis. So now I'm going to take a little bit of time and dive into how Trove is actually architectured and sort of how it works with the other OpenStack services. So Trove makes heavy use of the other infrastructure OpenStack services. So if you think of Trove, it really is a layer that sits on top of some of the other base services like Nova, Cinder, Swift, Neutron. So how does Trove use each of these other services? So if you look at Nova, Trove basically uses Nova to boot the actual database instance. So Trove has a database image in Glance that it says per data store. So if you per data store and data store version. So if we take the example of MySQL version 5.5, it talks to Nova to boot a MySQL 5.5 instance, and then prepares the instance and hands you the prepared instance. It uses Cinder because it uses volumes. So underneath the covers, it sets up your database so that the database's data files are actually being backed by the volume and not on the local disk. It uses Swift for backup and restore. Again, this is an optional component, but a lot of folks use it. So say if you're taking a backup of your MySQL database, it will stream the files over to object store in Swift so you can access it through Swift at a later time if you want. uses Neutron for networking and Keystone for identity management. So it works with Keystone tokens and the same Keystone tenants and Keystone users that work across your OpenStack services. Wanted to talk a little bit more about how Trove is architectured internally. And there's a lot going on in this diagram here, so I'm going to spend a little bit of time on this slide. So if you look at Trove, sorry, this is a misclick. So if you look at Trove itself, it has three main components. It has the Trove API, the Trove Task Manager, and the Trove Conductor, which are sort of part of its control plane. The Trove API is mostly there to receive API, to serve API requests. So say if you make an API connection to create a Trove instance, that reaches the Trove API. If you look at the Trove Task Manager, it's what does most of the heavy lifting and the orchestration of all the tasks that Trove does. The Trove Conductor basically orchestrates messages between the guest agent and the rest of the Trove system. So, which comes to another piece of Trove, which is the guest agent. So the guest agent is basically a Trove service that runs on the compute instance itself, which hosts the data store, the database. And the guest agent does things like prepare the database. So when I talked earlier about tuning the database and securing the database, the guest agent is what does that. So at a high level, how the system works is an API call is made to the Trove API. The Trove API communicates via the message bus to the task manager. So let's take an example of creating an instance, right? So Trove API receives the create instance call. It checks the database, makes sure you have quota to do it, checks to make sure your token is valid, it does all of that, and then talks to the message bus and drops in the message for the task manager to actually do the heavy lifting and orchestrate the creation of the instance. And then basically sends a response back saying that, okay, I accepted your response, but it's an async task. So the Trove Task Manager gets the message. Once the Trove Task Manager gets the message, it talks to Nova and basically says, spin me up an instance of this particular data store, in this case MySQL, using this particular image, which it pulls from Glance. So the guest images are registered in Glance. Once that Nova instance comes up, the Trove guest agent, which is baked into that image, automatically starts up and starts listening to the message bus for messages. And the first message that the Trove Task Manager drops for the guest agent is the prepare message. And that's so that the guest agent can secure itself and prepare itself and make sure that the actual data store, in this case MySQL, is up and running. So once the guest agent gets the prepare message, it goes through its little dance of securing it and making sure that stuff is tuned. And once the guest agent is up and running, the guest agent then sends a little note back to the message bus that says, okay, the MySQL is up and running, I have a heartbeat, and it's healthy. And then the Trove Conductor listens to that and basically updates the state of the guest instance in the Trove database. So this database here is basically the Trove database. It's not the database that you get handed when you request a MySQL or a Redis database. This is just to store the internal state of Trove itself. So we talked about that compute instance. The database data is actually on the Cinder volume, which also gets provisioned through Cinder, just as the instance gets provisioned through Nova. And the backups don't actually get created until you make a backup call, which is a separate API call that you can issue at any time to Trove to take a backup of an instance. You'll see that Keystone and Nova Networking or Neutron are on the side here because we do make use of them, but they're pretty much all pervasive throughout the infrastructure, so identity management and networking being those two things that sort of live everywhere. So I know there's a lot going on in this slide, so if you guys have questions or anything specific. Yeah. Trove is dependent on a message bus. Usually there's an AMQP service like RabbitMQ or. Yes. So this is. No. So usually the way Trove is deployed is folks deploy a different message bus for Trove so that you don't share the same one as Nova. Because usually Trove is deployed as an application in the cloud and not under cloud, and there's security implications of sending messages from inside the cloud to under the cloud. So. Okay. Yep. Yeah, so one of the reasons that I'd recommend this not to be the same message bus as the Nova one is because this usually tends to be instances that live in the customer's tenant. And so you don't want, sometimes can be, and so you don't want the message bus to be connected with, say, for example, the Nova's message bus. Great question. Any others? Okay, moving along. So now that you know a little bit about the Trove architecture, I want to talk a little bit about modularity in Trove and how so we talked a bit about the control plane and the different parts of the control plane and how the guest interacts with the control plane. But the guest itself in Trove is modular. And so the guest agent in Trove has a concept of what are called strategies. And this is for tasks that the guest runs. So things like backup or replication, restore, or storage. For example, where should I back up my backup files to? Do you want me to back them up to Swift or local storage or a Cinder volume somewhere? So those are all encapsulated in strategies. And so if you look in each of those strategies, so for example, if we take the example of backup, you'll see that there's a base implementation for the strategy, but also there's implementations for the different data store types. And not just that, for each data store type, there can be more than one type of strategy, and you can specify which type of strategy, which of these strategies you want to use in your Trove implementation in the config file. So for example, in the case of MySQL, there's 2 strategies that exist for Trove today. Actually, 3. There's MySQL dump, InnoBackupEX, and InnoBackupEX incremental. InnoBackupEX and MySQL dump being 2 of the most popular tools that are used to do MySQL backups. And InnoBackupEX incremental also gives you the option of doing incremental backups, so you could specify another backup as a parent backup, and we'll talk a little bit more about that later. But just to give you an idea of the guest code, and so the concept of strategies and modularity there.
Is the strategy like a Python object with this method on?
So it's a very basic class that can be loaded at runtime. It uses stevedore to do loading mechanisms, dynamic loading mechanism. But the base strategies do, so for example, the MySQL-based strategies do enforce certain things about the strategy. So for example, the strategy can only be used in the case of MySQL, these particular data store instances and stuff like that. So at the very general level, they're just Python classes. But as you move down the chain and become more specific, there's some more enforcement of functions that happen. So that was a bit about the architecture of Trove. So now that you guys know that, of course, you want to go out and play with Trove, right? So where can I get Trove? Trove is made up of comprises a few different OpenStack projects. The main project is the OpenStack Trove project. It's in the OpenStack Git repos, mirrored on GitHub, so you could just use your web browser, get to GitHub, or clone the project from there. Apart from the main Trove project, which has the control plane and the guest agent, there's also the Trove Python client bindings and the command line client, and the standard naming convention Python-Trove client, and it's on GitHub as well. There's also this repo called Trove Integration, which has scripts that let you get started with Trove quicker, that help with like installing Trove, building Trove guest images and things like that. So that's also on GitHub. But if you're a developer, you probably want to check that piece out first. And finally, there's Trove Specs. So just like all the other OpenStack projects, we moved to Specs and doing spec reviews in Gerrit. And specs that are approved are in this repo in Trove Specs. So if you want to look at, hey, what is being delivered in the next new milestone, what new features are coming out, you could take a look at the Trove Specs repo and if you're an operator and would like to give feedback on that, that's a good place to go. So that's the code, but now I have the code. How do I get Trove up and running, right? So the easiest way, like I mentioned, is if you clone the Trove Integration scripts repo, and then there's a script called redstack install and redstack kickstart with the data store name. So internally, redstack install calls into, we'll clone devstack for you, we'll set up devstack, and set up Trove as part of devstack. Redstack kickstart MySQL will create a MySQL image and register it with your Trove install. If you don't want to get the Trove integration scripts and you just want to go off a vanilla devstack environment, you could do that as well. Devstack introduced the concept of plugins in Kilo, so there's a Trove plugin defined in the Trove repo, so all you have to do is add this to your devstack local RC, enable plugin Trove, and then the path to the Git repo. And devstack will pull down Trove and install it for you as part of devstack. And as a Trove user, if you're not really developing Trove, you could always get Trove from the HP Helium development platform or the Tesora DBAS platform as well. So those are sort of the platforms that I know that bundle Trove out of the box. So that said, I wanted to go a bit into the detail of the Trove API and what are the different API calls that you can make and what can you do with them. So the main one is provisioning a Trove instance. So this uses the standard Python Trove client, and that's simply just called Trove. The command would be Trove create instance name, and then you give it a flavor ID of how big you want your instance, and then a size parameter for what size of volume you want Cinder to provision for the instance. So support for flavors, it supports volumes using Cinder. You can also pass in optional parameters. So again, this one creates a database of the default type where a default type can be specified in the Trove config file, but you can also specify different types and versions. There's a Trove data store list and a Trove data store version list command that shows you the data stores and versions that are available for you to create Trove instances. So you could say, I want a Mongo instance, not a MySQL instance, or different data store types through this command as well. There's also support for AZs using -- availability zone. And where this gets interesting is since Trove can provision async replicas of instances, so MySQL master and MySQL slave, you might want to have them in different availability zones so that if one fails, the other is still available. So you can pass that information in as well. And we also support neutron networks using the -- NIC parameters, sort of like Nova. So if you want your Trove to be on a private neutron network that you've set up, you can pass that in, and Trove will put that instance on that particular network. So I spoke about the backup and restore API. Just a quick walkthrough of that. So Trove allows you to create backups from an instance, and the command is simply Trove backup create. Give it a backup name and an instance ID, and it goes off and creates the backup. So you can give it an optional description, or if your strategy to use incremental backups is enabled, you could specify a -- parent option, which is a previous backup. And so Trove will take a backup based on incrementally based on that parent backup. So it's only backing up the changes between when the last backup was taken and what the state of the instance is now. To restore your backup, basically you use the Trove create command, the same one that was on the last slide. In addition to the regular arguments, you also provide in a backup argument and say backup with the backup ID. So Trove creates a whole new instance and restores the data from that backup onto the instance. So your new instance is all of the data that was in the backup. A little bit about the backups in Trove. So backups are fully managed in the sense that you have an API to do backups and restored, and they're triggered and tracked via the API. Depending on the storage strategy you configure, and most implementations of Trove use the Swift storage strategy, which basically, whether you're using MySQL dump or in a backup EX, streams the resulting data to Swift, basically compresses it and streams it, and you have an option to encrypt it as well. It supports incremental as well as full backups. Underneath it leverages Percona's extra backup tool to do the incremental backups. And then you can also specify that you want to do a full backup if you don't want to use an incremental backup. So, any questions on the backups pieces?
Any database besides MySQL over the first class citizen? It seems very
So right now we have backups for MySQL, I believe Mongo. So it's one of those things that are under development. In Liberty, we will have backups for Redis and Cassandra as well, I believe. But so we're getting there. We just started with MySQL, and sort of the API is defined for that. Most of the folks on the team had requirements for getting MySQL up and running first, and then as we're gaining experience with some of these other data stores, we're adding more support for them. But you're absolutely right. And all of the features that Trove are up and coming in Trove first usually land in MySQL, and then a lot more say. There's a lot of communication that happens because a lot of the expertise for some of these other data stores don't lie with the Trove team themselves. And so we have to usually go talk to the Cassandra guys or go talk to the Mongo guys when we're implementing some of these other features. Any other questions on backups or anything so far? Mentioned a bit about replicas. This is again MySQL specific. You could create, so when you issue a Trove create command, you can also specify replica of, which basically creates a MySQL instance and sets up replication between the instance that you specify here and the newly created instance. So this basically gives you a way to create a master and a slave in MySQL. Pre-Kilo, we only supported binlog replication. Once Kilo came along, MySQL 5.6 came along, and they started supporting what's called GTID replication. And so in Kilo, we added support for GTID replication. So with binlog replication, you can detach an instance using Trove detach replica. But if you're using the GTID replication strategy, which is available only to MySQL 5.6 and beyond, you can also use these other couple commands called, which allows you to promote a replica. So you could do a promote to replica source, which basically makes a particular instance the master and makes the master the slave. Or you could do it, so say your master went down and you have no way to actually connect to it. You could do an eject replica source, which basically says, this master no longer exists. Let me look at the global transactions across all the slaves. If I have more than one slave, pick the slave that's the most up-to-date, the latest, and promote that to the master programmatically. So you don't have to make the call about, hey, which one is the latest, right? Because since it's async replication, you're not sure. Trove clusters. So this is actually, as a side note, this is something that landed for Mongo before it landed for MySQL. And the reason behind that was basically eBay, who was one of the contributors to Trove, wanted MongoDB clustering, and they had the expertise there, so they contributed this. So this was actually, MongoDB support was added in Juno, you'll see, and that was the first clustering support in Trove. Since Juno, we've added clustering support for Vertica, and in Liberty, we're looking at adding clustering support for MySQL clusters, MySQL Galera clusters, and Redis clustering as well. Redis just announced their clustering support in the 3.0 and later releases. So, but coming back to the Trove cluster command, the command is just cluster create. You give it the data store and the data store version. We check that data store and data store version is supports having clustered instances. And then Trove has a similar thing for clustering called clustering strategies. Under the covers calls that to actually set up the cluster. And then optional parameters to cluster create is -- instance, and you specify flavor ID and volume. And you just specify that multiple times depending on the size of your cluster, how big you want your cluster to be. So. there's a lot more that happens under the scenes here. I can go into depth, but if folks have questions. Just to give you a brief idea about what got completed in Kilo and where we're going in Liberty and what we're planning to complete in Liberty. So in Kilo, we worked on async MySQL G2 replication. Where we also worked quite a bit on adding Horizon support for replication. As most of you guys know, Horizon is the sort of UI for OpenStack. And so there's a Trove, a databases panel in the UI where you can create database instances and you can create backups. Since we just added replication support in Juno, we added the UI for replication support in Kilo, made sure that was working. In Kilo, IBM also started contributing to Trove, and so they added support for CouchDB and IBM DB2 single instance. They're looking into adding support for clustering for them, but that's not planned for Liberty. They're still looking into it for the M release. We also added support for HP Vertica. We added both single instance support and support for Vertica clusters. Using the community edition, so we're limited to 3-node clusters currently. We're looking to build that out and add support for clusters bigger than 3 nodes as well. Again, that's work that's going on for the, that's still in the design phase, and that's work that's going on for the M release. We added the specs repo for Trove blueprints, so that was important because that is sort of our signaling mechanism to folks, telling them what's coming in the new and upcoming releases. Plan for Liberty. Liberty 3, which is the feature freeze date, is almost here. So a lot of this stuff is underway and almost completed. So we're building out clusters, support for MySQL clusters through Percona XtraDB cluster, adding support for Redis clusters. We're adding backup and restore support for some of the other data stores other than MySQL, so backup and restore for MongoDB, backup and restore for Redis. We're adding configuration group support for Redis. Configuration groups are basically the settings that you can tune for the data store through the Trove API. So say, for example, you wanted to tune MyCon settings through the API. You can do that for MySQL, so something similar for Redis as well. And we're also adding this a method to associate flavors with data stores. Where this gets really interesting is certain data stores like Mongo or Vertica have minimum requirements and won't run on sizes RAM that's less than so many gigabytes, or have minimum sizes when it comes to disk space and things like that. So for those data stores, you could specify a set of flavors that they would run on, and Trove will keep that in mind and not let you create instances on flavors that are not specified in that subset. So that's something we're working on as well. Your idea here, so we're a growing community of contributors, lots of folks from lots of companies and lots of lines of code, always open to new areas and code, and lots of room for improvement. We would really, like we said, we're very MySQL heavy when it comes to expertise. If you're an expert in other data stores, or even if you just want to come and find out what Trove is doing and want to contribute, best way is to find us at OpenStack-Trove channel on Freenode. Come talk to us. We'd love to hear from you, even if you're not interested in contributing and have feedback, say, using Trove, this works, this doesn't work well, please come talk to us. We're always interested in hearing feedback. So, thank you. Time